Original process. The original process of Kirchhoff's laws, formulated in 1845, involves a step-by-step analysis of electrical circuits. It begins by labeling junctions and currents, then applying the junction rule, also called the first law of Kirchhoff's current law, which states that the sum of currents entering a junction equals the sum of currents leaving. Based on the conservation of charge, around this time, Kirchhoff's electrical experimentation relied on basic manually operated instruments and components. Kirchhoff's work would have involved direct current circuits. Did I skip one?
No, it was just two.
Original difficulties. Gustav Kirchhoff's initial difficulties were primarily related to personal circumstances and the theoretical limitations of his laws when applied outside specific ideal conditions rather than a general rejection of his work by the scientific community. Some other issues were his personal health and mobility. Some safety issues for Kirchhoff were incorrect calculations, component damage, high current densities, and forgetting components. Kirchhoff's processing issue consisted of sign conventions, setting up and solving simultaneous equations, and the fundamental limitations of his laws.
Original motivation. Kirchhoff's motivation was that he wanted to understand how electrical currents move through circuits, especially when there are a branch or junction, places where wires split or come together. We want a rule that could help scientists and engineers figure out how much current flows in each part of the circuit without I can't get guessing. Original benefits, functions for electrical engineering using in modern technology. To, take the technology. I cannot get that out. Technologies, power distribution, such as the fuse box in a car or computer system, diagnosing problems.
Modern process. Kirchhoff's modern law established two key principles for electrical circuits. Kirchhoff's current law, KCL, states that the total current at a junction is equal to the total current leaving it, reflecting charge conservation. Kirchhoff's voltage law, KVL, indicates that the total voltage in a closed loop must equal zero based on energy conservation. Today, these laws are applied using advanced circuit analysis software and simulation tools for modeling, designing, and troubleshooting complex circuits. Unlike the previous reliance on basic tools like pencils, papers, and physical measuring devices, current experimental methods for applying Kirchhoff's law involves constructing a circuit and using a multimeter to measure currents and voltages, then comparing these measurements to theoretical predictions. This lab work includes setting up the circuits, applying a known voltage, and confirming KCL and KVL. Modern differences. Modern advancements build on Kirchhoff's fundamental work in electrical circuits, extending his laws to new technologies and applications in areas like telecommunications, astrophysics, and quantum physics. Kirchhoff's modern protection/safety refers to two distinct concepts: the modern applications of Kirchhoff's circuit laws in electrical engineering for safety and protection, and Kirchhoff's principle, a modern cryptographic security concept. Kirchhoff's law protect electrical systems by helping engineers analyze current and voltage to design circuits that won't overheat or fail, ensuring safety and reliable performance, especially in complex designs like power systems and medical devices. Kirchhoff's modern information gathering can be interpreted in two ways, either as an outdated term referring to applying Kirchhoff's law in modern circuits or as a misunderstanding of the name, possibly confusing it with Kirchhoff's principle in cryptography. Kirchhoff's modern information processing likely refers to either modern applications of Gustav Kirchhoff's law of electricity in circuit analysis and computing, or the work of Michael D. Kirchhoff, predictive processing and self-organization in neuroscience and cognitive science.